So, we have been discussing quite a bit of theory of pattern recognition in several classifiers, and in some of the previous classes we looked at how the classification rules perform over artificial data sets. I already gave you some assignments on that. Today I shall discuss the utility of the schemes, the pattern recognition schemes on a real life data set. So, as you can see on your screen, satellite image data for the data analysis part. This satellite imagery is taken from NRSA Hyderabad. As you can see from there, it is 12 years old. Actually, it is probably more than 12 years old. I do not remember when we bought it. It may be even the later part of 1990s. It is a scene from Calcutta. It is a multispectral imagery. There are 4 bands there, and band 1 corresponds to blue, band 2 corresponds to green, band 3 corresponds to red, and band 4 it corresponds to infrared. The resolution is approximately, for each pixel, the resolution is approximately 36.25 into 36.25 square meters. That is, each pixel on an average it covers an area of that much, 36 into 36, those many square meters approximately. This is how the image from, the band 1 image looks like. As you can see, it is really very difficult for you to see anything there. Similarly, band 2, this is band 3, and this is band 4. The reason is that our monitors, they support 0 for black and 255 for white. So, if the maximum gray value is, let us just say, of the order of 60 or 70, then you practically do not see anything in the image. You practically do not see anything in the image. So, usually for these images, those people who are acquainted with image processing, they would know that one needs to do some sort of an enhancement. So, here what we had done was a simple enhancement scheme has been considered, so that the images can be seen properly. So, the enhancement scheme is simple linear stretching. For each image, you find the minimum gray value and the maximum gray value, and from each pixel value you subtract the minimum and you divide it by maximum minus minimum and multiply it by 255. So, that the minimum gray value in the original image, it corresponds to 0, the maximum gray value in the original image, it corresponds to gray value 255 in the transformed domain, in the transformed image. So, since it is a linear function, it is called linear stretching, since you are stretching the interval from min max to 0 and 255. So, you are stretching the interval. So, it is called linear stretching, a simple enhancement operator. Now, after you do the enhancement, this is what you are going to get. The enhanced image of band 1, it would look like this. I will show you some of the characteristics of this thing. You see this portion, this is basically the river Hooghly or Ganges. You see there is a bridge here. This bridge is known as Bali Bridge, and then when you come down here, you see another bridge. This is known as Howrah Bridge. Okay. This is Howrah, this is the famous Howrah Bridge, and this is Bali Bridge, and it is going down like this. And this was the second Hooghly Bridge, it was under construction in those days. So, and these black things, they correspond to pond areas. Okay. This is also, this black is also pond area, and this black, it is also pond area. The people who are acquainted with Calcutta, actually this is a pond practically in front of ISI. When you cross the BT road, you will get this pond. So, basically Indian Statistical Institute is situated somewhere here, and we are very close to Bali Bridge. So, this is band 1 image, it corresponds to the blue band, blue color. This is the enhanced image for band 2, that is green. Please note that the river water and pond water, they are different. This is the river water and this is the pond water. This black is pond water. This black is also pond water, and as I said, this is also pond water. River water and pond water, note that they are different. And this is band 2, that is green image, enhanced one. Here also, as you can see, the river water and pond water, they are actually different, they are giving different gray values. And then as you come slowly to this is red. Now, let me talk about training sets. What is the problem here? The problem is you need to classify each pixel into the one of the land cover types. What is the land cover types under consideration here? Here I want to do a simple problem where each pixel is to be put into one of the two classes. One class is river water, another class is non-river. Non-river includes the pond regions as well as you have land, and land includes buildings, and you have barren land, you have gardens, okay, and all the other things. Basically, I want to put each pixel into one of the two categories. One is river, other one is non-river. This is the basic classification problem under consideration. So, we have taken a training sample set. 50 points from the river portion we have chosen, 100 points from the rest they are chosen. Now, the question is how they are chosen. If you remember my lectures about how to take training sets and test sets, one of the things that I had always mentioned there, that training set should reflect the overall variation in the data set, so that you can estimate the parameters properly. Test set again should indicate the overall variation in the data set, so that whatever misclassification rate that we are getting on the test set, that should reflect the overall misclassification in the entire population. So, both the training and test sets, they need to reflect the overall variations within that whole population properly. So, here basically the test set means every point we are going to do the classification. So, that is basically the test set. I mean, so the training set is we are going to take in the whole of 512 by 512, they are totally 512 square pixels. In these 512 square pixels, we are going to take some small number of pixels, some 50 from the river portion and 100 points from the rest. This is the training set, and the test set is all the rest. All the rest, I mean, it is 512 square minus 150. This is the test set size, and the training set is 100 points from the non-river portion, 50 points from the river portion. Now, there can be first many questions. How these numbers 100 and 50 are arrived at? That is one question. And the second question is, once they are arrived at, how actually someone can choose these points? Now, the answer to the first one, how these numbers 150 are arrived at? We know that the river portion is small compared to the land portion, the non-river portion. So, the number of points that we are going to take for the training set for the river, it will be smaller when you compare it with the number of points that we can take for the non-river portion. Okay. Then once it is smaller, then this is probably I chose 50 and 100, some people can even take 25 and 50, but probably it should not be less than 25, because you would like to get the overall variation in the river class and overall variation in the non-river class. Probably it should not be less than 25, since I have been dealing with this data set. So, I do not really think it should be less than 25, because you would like to get the overall variation in the river class and of course, the overall variation in the non-river class. So, I think one should take at least 25 points from the river, and since you would like to get overall variation in the non-river class also, there it is 25 means it should be at least 50, 55, 60. So, I have taken 50 and 100. So, one can take even different values also. Instead of 50 and 100, one can take, let us just say 75 and 150, 75 and 125 or 50 and 125, one can choose many other values. So, I have taken 50 and 100. Now, the next question is, which 50 points from the river we have to choose, which 100 points from the land, from the non-river portion do we need to choose? The answer is, as I said, it should reflect the overall variation. Now, let us look at this portion. This is river portion. So, if you want to take 50 points, those 50 points should be distributed from this place to this place. Then we are basically reflecting the variations in the class. Similarly, the other 100 points for the land, you should try to take them as much as possible from all these regions. River is slightly easier, but the land portion is slightly difficult. Which particular 100 points you need to choose? The not exactly land portion, the non-river portion, it is slightly difficult in the sense that which exact 100 points are you going to take? That is, but nevertheless 100 points are chosen. Now, what are the features? Since for each pixel location you have gray value for blue band, gray value for green, gray value for red and gray value for infrared. So, each pixel location is represented by a 4-dimensional feature vector. So, the number of features is 4. So, we have chosen 50 points from the river portion, 100 points from the non-river portion, number of features is 4. Then there are 2 classes, as I said, river and non-river. Then after these 50 points are chosen, then you have 50 4-dimensional vectors for river, 100 4-dimensional vectors for the non-river portion. So, you calculate mean of these 50 vectors for the river, covariance matrix for the river portion. Similarly, you get mean and covariance matrices for the non-river portions based on the 100 points. Now, you have the mean and covariance matrices. Note that we do not know anything about the probability distribution. So, we will assume normal distribution. So, once we assume normal distribution, then we need to know the prior probabilities for applying the Bayes decision rule. So, for prior probabilities, we have taken 3 cases. One case is for the the river portion, the prior probability is 0.3, the non-river portion prior probability is 0.7. So, river portion the prior probability is 0.3, non-river portion the prior probability is 0.7. So, and using that we get the Bayes decision rule, then you take every pixel, get the 4-dimensional vector and classify each pixel to either to water, either to non-river river portion or non-river portion. River portion is represented by the gray value 255 in this image, the non-river portion is represented by the gray value 0 in this image. So, once that is done, this is the output. As you can see, the 2 bridges, the Bali bridge and Howrah bridge, they came out properly. Okay. the two bridges. This is also one of the reasons in my class also I give this example, since the river portion is known to all of us, one can easily check how good or how bad the classification is. You do not need to look at your misclassification rate, etc., one can find it from here directly. One can find all these things from here directly. You see, in the river portion there are many black dots. Okay. So, these points are misclassified, but then you see there is a patch here. This patch is corresponds to there the river got dried up, and this patch again it corresponds to the situation where the river got dried up. Okay. And there are some small dots here. So, these dots they are all misclassified, they are all misclassified, but note that there are some points here and there are some points here, the non-river portion they have come into river. So, there are a few points, but then as you can see most of the points, most of the pixels they are classified properly. Out of these many pixels, less than 1% of them are misclassified, less than 1%. So, the rate of correct classification is really high. Now, before I go further, let me make a few more comments. The first comment is that if you ask me whether similar results will be obtained with other training sets, I would say it is not guaranteed. I am repeating the same thing again. If the training sets reflect the overall variation, then your quality of result will be good. If they do not reflect, then the quality of result will not be good. It is not guaranteed that the result will be good. Since the same data I have been using for the past many years, and every year I give this one as an assignment to my students in ISI, some people they show me results which are worse than this, since they have not taken the training sets properly. If your training sets are not chosen properly, you are not expected to get good results. So, this one I am telling you repeatedly. If the training set is really chosen properly, now you see for 0.5 and 0.5 these are the results, and 0.7 and 0.3 these are the results. Since the training set is chosen properly, the prior probabilities are not making much of a difference, whereas if the training set is not chosen properly, the prior probabilities are going to make lot of difference. This I have seen very many examples. So, this once again reflects that your training sets have to be chosen, and there are no compromises here. Training sets have to be chosen properly. Now, the k nearest neighbor decision rule. Now, you can apply k nearest neighbor decision rule also. We have 50 points from the river portion, 100 points from the non-river. You take them as your training set. So, you take one point, say the pixel 1 1. So, it has its 4-dimensional vector. That pixel is to be classified to one of the two classes. So, from that pixel you calculate the distance of that pixel with all these 150 pixels. What is the meaning of the distance here? The distance is Euclidean distance, and you have 4-dimensional feature vectors. So, you calculate 150 distances and arrange them in increasing order or non-decreasing order, and choose the first k distances, and you look at the corresponding k points, see how many of them are class 1, how many of them are class 2, whichever value, from whichever class you get the maximum representation, you put the point into that class. So, since here we are only talking about two classes, and if I take k as an even number, it is possible that you may get from both the classes equal representation, So, I have chosen my value of k to be odd, and we are taking the same training sample set. This is the result for k is equal to 1. This is the result for k is equal to 1. Now, there is one point that I would like to mention here. Note that here we are not making any distributional assumption whatsoever, no distributional assumption, and look at the quality of the result, it is fantastic. The number of points that are misclassified, it is very, very small. This shows you the power of this rule, KNN rule. This is for k is equal to 3. This is for k is equal to 5. So, you are able to do the classification properly. Now, there was one question in one of the previous classes about how to choose the value of k. How to choose the value of k? Here I have shown the results on 3 different values of k. There is only very little difference, minor difference. This again reflects, let me tell you, the quality of the training sample set. If the quality of the training sample set is good, for very many different values of k, you are going to get similar results. You are going to get similar results. Now, this one, after we have done the classification, then we went into clustering, where we have to, in many situations we need to tell the number of clusters in advance, and we discussed a few clustering schemes. One of them is k-means algorithm, where k is the number of clusters, and for k-means algorithm the value of k is to be given as an input. Value of k is to be given as an input. So, on the same data set we did clustering, we applied k-means technique, and again for k-means algorithm there are several versions available. We used a 4Gs version, that is basically till the whole iteration ends, we will not change the cluster, we will not change anything. After the iteration has ended, then we have new set of clusters, and in the previous one you have old set of clusters. If these two clusters are same, then we stop it, otherwise again we go for next iteration. So, 4G scheme has been applied, and these are the different results that we have got. Now, for k is equal to 2, note that we are doing clustering means we do not know the number of groups or number of clusters. We are assuming that the number of clusters is 2, and then this is the output. Now, how much this output reflects the reality, that is the basic question. If an output should reflect the reality, then we need to get the value of k properly. If an output should reflect the reality, then we need to get the value of k properly, and we do not know the value of k. We do not know the value of k. So, we have tried it with different values of k. For k is equal to 2, this is the result. This does not actually say much about the grouping. I mean, we are not in a position to name the different clusters. This is for k is equal to 3. This again we are not in a position to name. This is for k is equal to 4. This is slightly better, but then let me just discuss this. This is for k is equal to 5. Look at this, this is the river water and this is the pond water, and wherever this black color is there, wherever this black color is there, most of it is water, Well, I do agree that this portion this is not water, this portion this is not water. Okay. But these portions they are indeed water, this portion is water. Okay. So, here these portions they are not water body. This is basically the main city area of Calcutta. This portion is Sham Bazar, and then you come down to Sham Bazar. This is Howrah Bridge. So, there is Shialda is somewhere here, okay. And this portion it is the Maidan portion. This is slightly better result. This is for k is equal to 6. Here river and city portion they are mixed up, but except that this is the pond water. Pond water this color you see at many other places also. But if you ask me, ultimately my conclusion is that they are giving you clustering. This clustering is sometimes some places some clusters are reflecting the actual reality, but I cannot make a uniform statement about any particular value of k. I cannot make a uniform statement about any particular value of k that this value of k is better than the other, I mean in all respects, that I cannot make, but these are the results that we have obtained. Well, this is a basic and inherent problem in clustering. They will provide groupings in the data set, whether those groupings reflect the actual reality or actual names that we are going to give to the clusters, that is not necessarily true. They reflect the groupings within the data set, then they may not correspond to the names that we would like to give. So, we have actually come to the end of the lecture series on pattern recognition. We tried to cover several topics in classification, clustering and feature selection in pattern recognition, but there are still many more topics that are left uncovered. One of them is syntactic pattern recognition, that is one, and among the usual techniques, some techniques that have not been covered are, you have decision trees, and kernel based methods, in machine learning, and you have other machine learning schemes like you have semi supervised learning, reinforcement learning, and you have Poisson forests, okay. And there are like that several other schemes are available.
Transfer learning also is separate.
Transfer learning, I already wrote semi supervised learning, reinforcement learning, and there are many more classification schemes. There are many neurofuzzy classification schemes available which have not been covered. There are many classification schemes available using some other soft computing techniques like rough sets and genetic algorithms, and in fact, there are many other schemes available. If I go on mentioning the names, you will get in fact many more names. Please take it as a lecture series for beginners. Please take it as a lecture series for beginners. Since we have covered only some portion, and there are still many other portions to be left covered, and whatever you teach here, there will be always some portions which will be left out. After all, the time is finite, but the number of things that you have to do, the syllabus is quite a lot. Please take these lectures as lectures for beginners only, and many advanced topics have not been covered. People who are interested in working on those advanced topics, they should read the corresponding literature, and they need to always compare whatever they read or whatever techniques that they are going to develop or use with, they need to always do the comparison properly among the techniques. That is one thing that I request all the users who are working or who would like to work on pattern recognition and related topics. They should do their comparisons properly. Doing the comparisons properly means you should take the, if you are taking the one training set, you should use the same training set for all the classification schemes. You should not change the training sets. Similarly, if you are using certain parameters for something, then you should use similar parameters for the other schemes also. From scheme to scheme, there are, suppose you would like to do reduction of features, you would like to reduce the number of features from 100 to 10, okay. You would like to reduce the number of features from 100 to 10, you have developed a scheme. Now, with some other schemes from 100 to 10 probably may not be possible, maybe it becomes 11 or it becomes 9, but it should not become 20 or it should not become 5. So, when you are making this comparison, be it with feature selection or classification or with any other thing, what you should do a proper comparison, that is really necessary. And nowadays, for whatever techniques that you are going to develop, if possible, if you develop the corresponding theory for the techniques, then the techniques will last longer. Since there is theory, one will always know the limitations of the method properly. If you know the limitations of the method, then you would actually know where to use it and where not to use it. So, if you can develop the theory for your methods properly, that will always be good, and in that sense the method also will last longer. But if you are not in a position to develop the theory, probably for a few years the method may be existing, and after that people will go for new methods. That is why you see in the latest literature for many journals, people, the associate editors and editors, they are actually asking for papers with theory. The main reason is that with theory you will know the limitations properly. Having said this, I mean it can be seen that developing theory is not an easy task. Having said this, it is not an easy task to develop the theory, but for the good of the subject, if theory is available, it will always be better. So, for all the users of pattern recognition and for all the persons who would like to work on pattern recognition, from my side and my colleague Professor Srikhendu Das side, thank you, and hope that these lectures will help you, and if you have any questions, you people can always write to NPTEL, and from there we will get those questions and we will try to reply to your queries. Thank you very much.